Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to deal with a different class of organic compounds, that is in as far as nomenclature is concerned. And today's topic will be on the nomenclature of a class of organic compounds that we call thiols. So without further ado, thank you and welcome. So as I have said, today we are going to learn about thiols. Thiols are a class of organic compounds that also have a Actually, their nomenclature is analogous to alcohols, but we're going to give different examples so that we can be able to know exactly which kind of format we can follow in learning this class of organic compounds. So in that case, we shall start by writing the functional group of this class of organic compounds that we are calling thiols. So in that case, thiols have got a radical, and then the functional group contains a sulfur hydrogen atom. So in that case, if we can see, there's a very slight difference in the structural formula of this, or just in the functional group of this particular class of organic compounds, in that if I were to name an alcohol, it will just appear like that. That's a functional group for alcohol, whereby R denotes a radical, and the difference, as we can see, is that for alcohols, instead of for thiols, instead of a whole group, they contain what we call a sulfur group. So in that case, their nomenclature is taking the same format. So we shall just proceed and see how we can be able to name a few members of this class of organic compounds. So in that case, we shall start with our basic format that we were writing. We had a suffix that we used to denote a nomenclature of this class of organic compounds. In that case, for thiols, the suffix is thiol. Of course, it starts with a small letter. I can just write the suffix is going to be thiol. As I have said that they take the format of nomenclature of organic compounds under the class of alcohols. So, and their name is derived from the class, of course, the alkene series. That forms the basic foundation for their naming. So the first member of this group will appear like this. If we substitute the R in this functional group to be the first member of the alkane series, then we shall have our thiol as that. So we write the regular formula for that as that one. So the name of that particular compound will be methanethiol. So in that case, that will be the name of this particular compound. Now, if you try to look at a section of the name, it has actually taken the whole name for the alkene series member. That's the first member, and then the suffix thiol. So we shall see whether this is the basic format that is used across the wide range of the members of this particular class of organic compounds. So let's proceed and try to look at the other members and try to see whether members which have a substituent can assume a different name, or is just the same format. So in that case, suppose we had a member of the thiol family that has got a structural formula of this kind, that is CH2, and then we have got a functional group here, SH, and another one at this particular point. So in that case, the SH, that is the sulfur hydrogen, is the principal functional group, as we have said. And in the IUPAC naming of this particular class of organic compounds, we add the ending thiol, as we have said, to the name of the alkane series without dropping the E letters we had given. For example, the first member that we had mentioned, we named it as methanethiol. So as we have been doing from the previous videos about the nomenclature of different classes of organic compounds, we have been dropping this ending for the basic alkane series that we have been using for other members like carboxylic acids, alkanes, alkynes. There are some instances whereby we have been dropping the E, but for the case of thiols, that E is normally maintained. So as we have said, thiols are analogous series of they are analogous to the alcohol series of the organic compounds. So there are other names. There is a different name that is used to refer to thiols, and they are called mercaptans. So in that case, mercaptans also is a different name for thiols. And we have said that their basic functional group contains an HH group that is joined to a radical. That's a functional group. So let's try to look at because that particular example that I had given. I've just given this name as a highlight so that in case I mention the term mercaptans, we shall be together, or maybe we shall be understanding why that specific term has been used. So let's just proceed from where we are left. So we had a 3-member group whereby it had 2 functional groups at these particular ends. And then for that case, we had this one as CH2, CH2. This is a 1, 2, 3. There has to be a CH2. This will be CH1. Just. Okay, it's a CH2. So in that case, we shall proceed and try to use the format that we have said in naming this particular class of organic compounds. So we said that we shall first of all try to confirm from the structure whether we have a longest chain of the alkane series of the carbon-carbon bonds, and then from this we can be able to see that this is a functional group and this is another one. So suppose we start naming from this point, we shall have a combination of the functional groups appearing at carbon number 1 and 3. So we shall have a combination of 1, 3. And then if we start naming from the other side, that is 1, 2, 3, then we shall have still the same designation for the carbons that have got an attachment of a functional group for thiols. So either ways, the solution is going to be the same. So which means we are going to number from either sides, and the prefixes are going to take the number. The numbering is going to be 1, 3, 1, 3. So that in that respect, we shall have the name of this compound appearing as 1, 3. And then this is a 3-member carbon group, so we have propane. We say that the names of the alkane series that are used in naming of this class of organic compounds maintain the E that we get from the alkane series. So for that case, we shall have propane. We have 2 functional groups. We said the name ends with the term thiol, so we shall have for that suffix, we shall have a thiol. So 1,3-propane dithiol is the name of the structure that we have drawn on the board. So thiols, just like another class of organic compounds, also can display members or a cyclic nature, which means some members of the thiol family can be cyclic members. They contain rings in that sense, so we shall have an example of that. So we have this member of the thiol family that contains serine, that's a functional group. That's at that point. So we see that this particular member has got 6 carbon rings. 1, 2, 3, 4, 5, 6. 6 carbon atoms. And then we have started numbering from the point of attachment. So we shall have the name. We said for cyclic compounds, the name normally starts with the term cyclo. And then we shall name the member of the alkane series that forms the foundation for naming of this class of organic compounds. So we shall have cyclohexane, and then we have the suffix as thiol. So the name for that particular compound is cyclohexane thiol. So that is it for cyclic compounds. And then we shall look at other examples, of course, of organic compounds that contain substituents, so that they can give us a clue on how we can be able to name compounds that have got a substituent in their structure. So we shall have, let's look at one example of that. This is a CH, 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 CH. So that is a 4. Then we have a metal attached at this point. So this is 2, 3. This is 3. And I have CH3, and then CH2, 2, CH2. And then we have a functional group there. So we have a 1, 2, 3, 4. Okay, this is 4 or 8 ways we can name it using this order: 1, 2, 3, 4. So we have 2 rows for this particular compound. So we shall be able to name this compound in